Hi everyone, welcome back. In this video, I'm going to continue with 5.4 non-Mendelian genetics and the clues to help you recognize them for chi-squares. Now in this video, I'm going to focus on sex-linked traits and more specifically, the X-linked recessive traits. So this is going to go in your recessive section in your notes. So we had already talked about how recessive genes are hidden by the dominant factor. And in X-linked recessive, it's a little bit different because of the X chromosome. So we have XX and XY. And in order for a female to be able to express an X-linked recessive characteristic, she would need both of her X chromosomes to contain the gene. And so we're going to indicate that with an X and a little line through it. Now for the males, because they only inherit one copy of the X, if they get the affected X, then they are going to be affected. And so an example of this is red-green color blindness. Now, in the case of a chi-square, when you're looking at a chi-square and you reject a null hypothesis, you're going to see a different pattern of inheritance, but you would also need to be able to see the sex of the organism, the sex chromosomes as well. So if you're rejecting a null hypothesis, then they would need to give you data about how it's inherited in females versus how it's inherited in males. If you see no difference between male versus female, then it's likely not to be sex-linked recessive. But in the case of sex-linked recessive, it does tend to show up in males more often because all they need is one copy of that X chromosome with the affected gene on it, and they're going to show it. Whereas females must be homozygous recessive. And so females are not going to be as likely or as evident because they've got the other X chromosome to compensate. Now, where you will, so when you're rejecting those null hypotheses, you've got to see a discrepancy or a difference between the way the females are affected or the males are affected. Another thing that's going to help you if you're going to reject this null hypothesis is the pedigree. So when you're looking at sex-linked recessive pedigrees, there are a few clues you can see and spot to help you identify whether or not this is sex-linked recessive. So in a very simplified form, let's take a look at this. We have a couple that has two children, and the female, let's say the female is affected because she has the two X chromosomes that are affected. So when we look at this pedigree, this female is going to give one of the affected X chromosomes to her daughter and one of the affected X chromosomes to her son. So her son should be affected. The father, on the other hand, is going to give his daughter an unaffected X chromosome, which is why the daughter is unaffected, and he's going to give his son the Y chromosome. So his X chromosome doesn't help his son out in any way. And so if you see an inheritance pattern like this, where you can find females who are affected and their sons are affected, you're off to a good start. Now, this may not be exclusively sex-linked. This could be other characteristics as well. But what you want to do is you want to see if you can disprove that this is sex-linked. So you want to find a way to be able to say, this is definitely not sex-linked because of these inheritance patterns. So here's what you would look for. So in this example here, our mother is affected, or the mother is affected and the father isn't. So same scenarios here. But now I'm showing that the son is unaffected. Now because the son has to inherit his X chromosome from his mother, he gets the Y from his father. If the son is unaffected, that tells me that this is not a sex-linked recessive pedigree. This can't be, because he's got to inherit this X chromosome from his mother. So that is what you want to look for. Affected mothers, if it's sex-linked recessive, must pass the affected X chromosome to all her sons. If you can spot a section of the tree where an affected mother does not pass it to her son, you can eliminate the possibility that this is sex-linked or X-linked recessive. I hope this video was helpful. Thanks for watching. Bye.